This podcast is sponsored by AppDynamics, a leader in business and application performance monitoring. Optimize app performance, increase team velocity, and drive business with end-to-end visibility, from code level to customer experience.
Welcome to the InfoQ podcast, a software engineering podcast brought to you by the same team behind InfoQ.com. InfoQ.com is a software engineering news site which aims to help progressive software development teams adopt new technologies. We are also the people behind the International Software Conference, QCon. I'm Werner Schuster, and as most of the industry, I've become more and more curious about data science. And in that context, one name keeps popping up, the language R. As luck would have it, our guest today is Martin Hadley, technical lead for the interactive data network at the University of Oxford and an independent data visualization consultant. And he's been deep into the R community for a while. Hello, Martin.
Hey, how you doing, Werner?
I'm excellent that you're here. Let's kick things off and talk about R a little bit. Maybe for our audience, can we categorize the language R a little bit?
What I think is really fun about R is that I work with a huge number of users who don't really realize that R is a language. They think of it as a piece of software. That's particularly true for the researchers that I work with at Oxford University. They're using RStudio, they're opening it up and importing data, and they're using lots of wizards inside of RStudio, and they don't really realize they're writing code and they're programmers.
So are there some R features then that make it better suited for data science than languages like, I don't know, Java or C or others?
Well, one of the really good things about R is when you want to work with rectangular data. So if you want to work with numerical arrays, then I'd say really don't use R, go and use something else. But if you've got rectangular data, which is coming from a database or from spreadsheets or other flat files, then R is really king. So if you've got lots of different types of data in your table and you want to summarize that data, you want to say, how many observations do I have of data in this category, in this subcategory, then R is really great at that. So it has something very similar to the data frame from Panda in Python. It's actually got a couple of different implementations of data frame as well, which can be challenging for new users to get their head around as well.
So what's a data frame? Is it just rectangular data like in R?
Yeah, so a data frame is just rectangular data. So you have column headings, you can access columns via their name as opposed to just via their index. There's a couple of different versions of data frame. There's the what we call base R version of data frame, which is what you get for free when you install R. You just have this data frame thing. But it's kind of dated and it has a number of really irritating features. So there's a new version of data frame, which is a new hotness called Tibble, which comes from the Tidyverse. And that came about in about 2015, and I think it's going to become huge, and people are going to move away from using base R to using the Tidyverse and using this Tibble. There's also a version of data frame which is designed for huge data. So if you're working with very large data sets, then Tibble and base R just won't do anything for you. You need to move over to data.table. But data.table is sometimes used by people who prefer the indexing rules. So data.table indexes by row then column, unlike data frame and Tibble, which does column and row.
So are these different data frame implementations, are they compatible? Do they have the same interface, or do you have to write code specifically for the base R or the big data one?
So I think that you can pretty much use the base R data frame and Tibble interchangeably, and it's very easy to convert between the two. But data.table is kind of fundamentally different, and you do have to be aware and go through some steps to massage your data from a Tibble over to a data.table.
It's interesting, you mentioned this word Tidyverse. I think we might also, and you also mentioned different implementations of data frames. Maybe we should also talk about just what R is, or who develops it, or who owns it. Can you give us an overview of what implementations we have, who I have to deal with?
Yeah, so R's been around for quite a while. So R really started becoming popular in the late 90s, particularly amongst statisticians, which is why people think about R as a stats application to install on a machine. And the R consortium came about and started to put money into the R Foundation to look after R, and this became what we call CRAN, or the Comprehensive R Archive Network, which is the package manager for R. But R itself, this CRAN version of R, it's not that efficient, so it doesn't bind to any of the MKL libraries for matrix operations. If you want to do things efficiently in R, matrix kind of operations, then you want to go and use a different runtime of R. One of the ones which I hear really good things about is the Microsoft R implementation, which used to be called Revolution Analytics, and then Microsoft brought them up. And there's a couple of other ones as well. So if you work in the pharmaceutical industry, then you probably have heard of Mango. So Mango provide a validated instance of R. So they re-implemented a language to use the MKL libraries amongst a number of other things. And they've gone through the most popular libraries or packages from CRAN and validated them. So said, yes, this is doing what it's doing. You can do this with your medical trial data and you're not going to get the wrong results. And they build this thing called valid R. So there's lots of different places you can get R from. Most people use CRAN, but you shouldn't be using CRAN. If you want to do things efficiently, you should go and use the Microsoft R runtime, in my opinion.
Interesting. And so if I want to use the Microsoft system, do I have to license it or pay for it?
No, so you can use it for free. If you want support, then yeah, there's a version of it where you can pay for support. Mango, the validated R instance, that you have to pay for that, but CRAN is completely free.
So I'm interested in Mango. When you say validated, what does validation involve? Is it just correctness or something else?
Mango's validated version of R essentially implements a bunch of tests which you can access to see, does this code do what I'm expecting it to do? And that's particularly important if you're doing things like calculating, if you're doing hypothesis testing, you want to know, is this test actually implemented in a way that I think it should be implemented? So that's what the validated R runtime from Mango does, is it says, if you do this, you will get the expected output.
So what's the rest of the ecosystem like? So you mentioned package systems.
So there's a sprawling ecosystem of packages available through CRAN because it's very easy for anybody to build an R package and then one can submit it to CRAN. And what CRAN do is they do what any good package manager do. They make sure that it can be installed on macOS, Windows, and a couple of different Linux distributions. And if it can, they say, that's good enough, we'll just have it. And that means that you have lots of packages there which are only good for one thing, and maybe they're not even that good for that one thing. So people often have like a huge collection of packages that they load because they want to do these specific things, and rather than implementing it themselves, they hear from a friend, oh, this package, this allows me to do this, so I just use this, and then I use this other package. So there's a big proliferation of packages problem inside of R. So RStudio, I think, are trying to make this less of an issue by building this ecosystem of packages or libraries called the Tidyverse. So these Tidyverse libraries are all designed to work together, and they all use Tibbles. They do things very efficiently. They bind to databases really, really nicely, because previously to the Tidyverse, it was relatively hard. Well, it wasn't relatively hard. You just had to think about connecting to a database, whereas now you don't. You just need to load the Tidyverse. In fact, RStudio make it so easy to work with the Tidyverse. There's a library called Tidyverse, which just installs all of the packages from Tidyverse for you, ready to use.
So Tidyverse is basically the first port of contact, basically.
Yes. So when you install R, you get what we call base R. So that includes a couple of standard packages, including stat and utils, which provides you with the data frame I mentioned before. I'd recommend to anybody starting R now, install R, install RStudio, and then install Tidyverse, and start using Tidyverse from the get-go to get your data into R, to reshape it, and to understand it.
So we've touched on this before a little bit, but so who uses R? Is it mostly the people who get the data, people who understand the domains? Is it programmers who want to analyze something?
So I think the people who use R are mostly data scientists and actually academic researchers. So people who are collecting data from surveys or they're doing some web scraping. R is actually quite good at web scraping. There's a couple of nice libraries which are Tidyverse compatible for web scraping. And then understanding that data is really what R is powerful for. And that's why I think data scientists, particularly in the back end, are using R. But R is also very good actually at creating visualizations. So if you have a data set and you say, well, I know this finding is true, I need to persuade my manager that this finding is true, then R is a good solution to that because it's very quick to go from importing your data to creating a little summary and then communicating out a visualization. So I think that R is really good if you want to say, I need to persuade somebody of this thing so they'll listen to me so I can do this with the data. I think R is really quite good for that.
Well, it's interesting. You mentioned doing visualizations and other things. So let's go to, we've installed R and RStudio. So how do you program R code? I mean, do you write large packages and then run them somewhere, or do you have a concept of notebooks or something else?
Mm-hmm. So many people are just writing script files inside of RStudio, so just standard script files. But RStudio does provide a really nice notebook interface. So it implements something called RMarkdown. So the notebooks are really good because it allows you to combine text with code and with code output as well. So RMarkdown allows you to output a couple of different types of document. So one can output HTML from RMarkdown. So if you want to create an interactive report with some visualizations in it, RMarkdown is really great for that. You can also output a PDF. And if you're in the unfortunate situation of having to work in Microsoft Office, then you can also export out Microsoft Word documents from RMarkdown as well.
And so what do the notebooks look like? Do they contain the results?
Yeah, so the notebooks include any text that you want to write. They also include the code, and they also include the outputs. So they look very much like Jupyter notebooks. I massively prefer working inside of RStudio on our Markdown notebooks because I really don't like doing my work inside of a web browser. I feel a little bit uncomfortable about using Jupyter inside of my web browser. Our Markdown notebooks are very, very similar to Jupyter notebooks.
But there are other services, I presume, that offer R in Jupyter.
Oh, so actually you can use R inside of Jupyter as well. So if you're familiar with using Jupyter notebooks, then you can just run R. You can run R code from an R kernel. But what Jupyter notebooks doesn't support that R Markdown does support is the inclusion of HTML widgets. So HTML widgets are interactive visualizations that you've built in R.
So does RStudio also have the typical IDE systems like debuggers, profilers?
Yes, so RStudio is a really great IDE. It's got really good debugging tools. It's very much like a traditional IDE, but it has been designed for a non-expert user, somebody who doesn't come from a programming background. It's got a lot of wizards for importing data, for processing data, and also for getting data outside of RStudio as well. So just exporting your data as flat files, it has wizards for doing that as well. But if you're a programmer and you say, I want to do real programming with R, then RStudio is the IDE for you.
It's pretty much a one horse town, basically.
Yeah, it's definitely a one horse town. There are no other horses. All the other horses saw this horse and just said, no, I'm not going in that town.
Okay, that's always good to know. I don't like horsey competition.
Yes, agreed.
So I think we've touched on this already. So the workflow for R, how do you, as a data scientist, how do you usually start your work? Do you fire up your RStudio in the morning, then import your data, work through it, and figure it out? Is that how it works, or some other way?
That's very much how it works for the majority of users. So most users are using RStudio on their local machines. It is also possible to use RStudio on a server, and we can have a talk about that. And I think it's important to talk about how we can get R to work on the web. But yeah, most R users will just flip on their laptop, open up RStudio, and start importing data. And they'll work through this really nice workflow, which the RStudio folks have put together, which is import, tidy, and then understand your data. And they talk about understanding your data as being a process of iteratively transforming, modeling, and visualizing it. And there's a lot of different tools inside of the Tidyverse for doing that. And then when you're finished, communication is really key. And it's really easy to communicate your data outside of RStudio because they have R notebooks. They have even a publishing platform for these R notebooks. So if you've built a HTML R Markdown notebook, then you can publish that for free to this open publishing platform called RPubs.com.
Those are then static notebooks, right? That's the code and the visualizations output, or can I evaluate code in these?
So no, you're absolutely right. You can't evaluate code in there, so it's not like the Azure notebooks that Microsoft provide. So they're static in that sense, but any interactive elements that you've created, so any HTML widgets or any Shinyapps that you create, they'll be interactive inside your HTML document on RPubs.
Oh, so they have, it's like a plot or something has its data embedded in JavaScript or
yes.
some other way.
Yeah, exactly. Yeah.
Oh. So it's also sort of offline usable.
Yes. Yes.
Okay, that's pretty useful. But you've already touched on this, but let's talk about the sort of deployment story of R. I mean, the web story, or can you tell us other ways of deploying R code or shipping it to users and making it available?
So if you want R as a service, then what you want is you want the horse from the town that we were talking about before. So RStudio make a server version of RStudio, which is really, really excellent. So it allows multiple users to work on the same projects, and that is kind of where you have your code running. So you have a server with RStudio on it, and you have your R code running inside of that. And then if you want to create interactive web applications with R, which you can do, then you want to use Shiny. So Shiny is this really nice framework for building interactive elements using R, and RStudio have a hosted solution for that. So you can publish your Shinyapps, as they're called, to shinyapps.io. And if you want to run your own instance of Shiny Server, then you can use the open source licensed Shiny Server application, which you can use for free. Or if you want a support model, then you can go to the charged version of Shiny Server as well.
Okay, so that's plenty of options, I think, there to publish your work.
Yes.
So this all sounds pretty exciting, but who doesn't use R? Or are there groups that can't use R for any sort of number of reasons? Are there any people that you can think of?
Well, so I think everybody should have R as part of their toolkit. It's really good for saying, I have some data, I want to understand it, I want to tell somebody else what this data says. It's really good for that. But if what you want to do is you want to do numerical simulations and you're not working with rectangular data in multiple types, you're working with numerical data, then I don't think R is the language or the tool for you. I think you'll have a much better time and a much better life if you move to a different town, and that town might be called Python. Also, there is an issue actually, which I forgot to mention, that R itself is licensed according to the GPL license, as are all of the packages on CRAN. So there's an interesting question at the moment, which was discussed at this year's Use R conference, about whether it's possible to monetize an R package, whether you can charge for an R package, or whether it's possible to receive donations. And that conversation, as I understand it, is still ongoing. So those are the two people I think that would struggle with using R: people who need raw speed for numerical simulations, and people who care about the licensing on the packages that they develop.
I think you've spent some time teaching R to all kinds of people, or I think you're still doing that. So can you tell us some experiences about teaching R to people who are programmers, who are not programmers? What are some of the obstacles?
So I think R can be quite frustrating for people who are programmers to learn, because you're going to want to control the flow, everything yourself. You might come from a functional background, you might come from a procedural background, and you just want to do everything yourself. And in RStudio, in R, which effectively becomes RStudio for a lot of people, that's just not the way that you want to do things. What you want to do is you want to use these highly optimized packages from the Tidyverse to quickly import your data, to understand your data, and to create these visualizations. What you don't want to be doing is you don't want to be writing your own for loops. You really don't want to be writing for loops inside of R, actually. You want to go to a more functional, you want to use functional constructs like lapply and the map functions, which are provided to you by the lovely per library from Tidyverse. Actually, one of the best things about R, I think, is the branding for the packages. So a ton of these packages have really beautiful stickers. So if you care about laptop stickers, R is very much a language for you, I think. It's also an obstacle, I think, teaching people who've been using R for a number of years and have this Rube Goldberg setup of different libraries, and trying to tell them, well, this is really inconsistent, and also most of those libraries that you're using right now, they're no longer being updated. So a future version of R could easily make those libraries just not work at all, and trying to persuade them to have a more consistent approach to the way that they do data science in R, I think is challenging. I think that the Tidyverse makes this much easier, but the Tidyverse only really started being built in 2015, so there's still a huge number of people who don't know about it. And there are some people who are not going to trust the Tidyverse. They're going to say, okay, well, this is a good collection of packages, but is this going to be maintained? And I think we can trust this to be maintained because RStudio are throwing a lot of their weight behind it, and RStudio are a really, really nice company.
One question about the development of R. As you said, that people have older packages that might not work in future versions. The developers of R, are they interested in keeping backwards compatibility? Is that a big topic there, or do they like to move fast and break things?
So they don't really like moving fast and breaking things. They do keep the language updated. So there's probably about four updates to base R a year. They don't like breaking things. They do break things sometimes. But they don't move fast. Nothing moves fast in the R universe.
Are there any sort of exciting things coming up in sort of the next year? Maybe language features that change things, or anything else?
Well, I think that the proliferation of the Tidyverse is going to be quite exciting. So it was only really in the beginning of this year that RStudio released their book, which I'd highly recommend to anybody, which is called R for Data Science. Now, I always forget the name of the second author for R for this book, because names just don't stick in my head. So R for Data Science by Hadley Wickham and Garrett Grolmund is an excellent book, which I'd recommend to anybody. And I think that the proliferation of that and this really neat new approach to non-standard evaluation inside of R, I think is really, really exciting. So we have a new way to do non-standard evaluation in R, which is called TidyEval. So RStudio are obsessed with this tidy verb, and TidyEval provides us really neat, nice ways of doing things that before were kind of inconsistent and not very nice using this framework called LazyEval. So I think that for package developers and people who are programmers who are new to R that want to make a name for themselves, I think that this TidyEval framework is going to be very useful for them.
Interesting. Okay, so you've already touched on it, but let's wrap this up by maybe you can tell us where you get your information from about R, or what resources can you recommend to people who are now interested and want to learn more about R?
Mm-hmm. So the place that I live pretty much every day to learn about R is Twitter. Twitter is excellent for finding out what's new in the R stats world. And I say R stats because R stats is the hashtag, and that goes back to this idea that many of the people that are using R don't really know that it's a programming language, or don't feel that they're writing code, at least when they're using R. So hashtag R stats is where I spend a lot of my time. I also spend some time on the Tidyverse hashtag. There's a couple of really high-profile tweeters, I think, that I follow. So Hadley Wickham, the author of that R for Data Science book that I mentioned before. He's prolific and he's very good at responding to people, including me, with questions of what's going on, what is this new Tidyverse, Tidyverse framework, and how to use it. There are a lot of good people to follow on Twitter, on the RStats hashtag. I also keep up to date with the RStudio blog, so that's really good for having an understanding of what RStudio are doing with their IDE and what they're doing with this Tidyverse ecosystem of packages as well.
And finally, I think you're doing some interesting stuff. You're also providing some resources on R. Maybe you can give us a very quick plug.
Yeah, that's good. Thank you. Yes, so I am a content creator for lynda.com, which is a subscription learning service that covers lots of different topics, including software development. And I have 2 new courses which are coming out at the end of this year on R. So one of those is an introduction to the Tidyverse, so to get you up to speed with Tibble I was speaking about earlier. And the second one basically gives you a high-level overview of the different HTML widget libraries that are available. These HTML widget libraries, they're bindings to popular JavaScript visualization libraries like Highchart, Plotly, and D3. Oh, and Viz.js as well, which is a wonderful library I shouldn't forget about. So those 2 courses are coming out, and I'm also doing some work with Sage Publishing for an interactive data visualization course, which is focused on social scientists. So I'm doing lots this year.
Excellent. Well, I think this was a very concise 30 minutes, and our audience will now know everything about R to get started and more. And thank you very much, Martin.
That's excellent. Thanks so much, Werner.